Okay, so we've got a question here. A car is valued at £20,000 when it's brand new. So that's as it leaves the forecourt. After 1 year, the car depreciates £4,000 to £16,000. What we want to know is what is the car worth after 10 years? So how are we going to go about calculating that? So what we do know is that a car's depreciation will look something like this. So if that's the cost of the car when brand new, as it depreciates, it will come down quite sharply and then just fade away just ever so gradually after that. So each year the loss will become less. So if you just draw it like this, then this gap here, you can see there to there, this gap is shorter than this gap. So it's not a straightforward linear equation. So what we need is an exponential function. So how are we going to go about doing that? Well, what we need is the initial value. So we'll call that the value of the car. Okay, and that equals the first value, £20,000. So we'll let's just call it C equals 20,000. So C for car. We'll just use that rather than use A or whatever because it's a car. So 20,000, and then we'll multiply that by exponential of T, where T is years. So after 1 year, we're down to £16,000. So here T will be 1. And then we'll multiply that by some constant K. So K, this is a constant of depreciation. So that's going to be just some random value that we can put in there where that'll help us to keep to this model. So how are we going to find K? That's what we need to do. So K equals what? Well, we know that when T equals 0, it's £20,000. And when T equals 1, it's £16,000. So here what we can do is, so we can put V at year 0. This is £20,000 times E to the T, which is 0, and then K. That looks like OK, but it's 0 times K. Well, anything to the power of 0, so we know that E to the power of 0, that is 1. So therefore at V0 it is still £20,000. So that model is still good. So now what we need to do is for year 1. So V1, so that will equal £20,000. E, now put in a 1 times K, and that will give us 16,000. Okay, so we know 20,000 times E to the K is 16,000. What we need to do is to find K. So now what we can do is maybe just do some algebra and isolate this K. So first of all, let's divide both sides by 20,000. That way then we get this constant out of the way. So our next line, we can bring this over here. So E to the 1K equals 16,000 divided by 20,000. Well, we can see straight away 16,000 divided by 20,000 is 4/5. Okay, now we've got E to the 1K, we'll just write that as E to the K. So let's just tidy that up a little bit. So E to the K equals 4/5. Now to isolate the K, if we take the log of both sides, we get the K on its own. So if I just put this log in here, and then I just bring that across, give yourself a bit of space to write the log in. Natural log of 4/5. So So this is natural log, so log base E. So ln equals log base E. We now see that this and this will cancel out, and we could do a bit of simplification on this if we wish as well. So now we've got k equals log of 4 minus log 5. So now these are two constants. We just type these in our calculator, see what we get. So log of 4 minus log of 5, and that's minus 0. Put the minus there, 0.22314. I think that's enough digits. Okay, so now we know what k is. So now we can cross that out and put minus 0.22314. Okay, so the final question is, what is the value after year 10? So we could just write down here V10, so the value on year 10. Still need the 20,000, that's the initial value. Multiply by E. K, we now have this one, and T is the years, that's going to be 10. So 10 times minus 0.22314. We can just type this into the calculator, see what we get. So 20,000 times the exponential so that's 10 times that is going to give us minus 2.223. So if we cross that 10 out, we'll have minus 2.22314. That's going to leave us with 2,147. 2,147 pounds and a few pence. 55 pence to be exact, but I think that's enough. Okay, so that's our value after 10 years.